Hey everyone, a very good morning and welcome back to my channel. My name is Akriti. I hope you all are doing well. So let's solve today's question. This is the question of today's contest, which is Leetcode 3196. Maximize the total cost of alternating Subarray, right? So basically, we are given an integer array nums with the length n. It means that array having n elements and the cost of the Subarray nums of left to right, where these left will always be greater than equal to 0 and right will always be less than n for sure, is defined as the cost such that the first element will be positive, and then we will alternatively keep on flipping the sign of the element. And yeah, so this is the cost of a summary, which is starting from the left pointer and ending at the right pointer, right? So we have to split our given array into subarray as many subarray as we want, and we have to make sure the total cost of the subarrays should be maximum, right? So you can split the subarray into any subarray. You can split your array into any subarray you want, and even your case can also be zero, where you will not split subarray, where you will not split the array into any subarray. And the count will be one, right? So basically, suppose this is your array, and now here you can split it into any subarray you want, any number of subarray you want. Like suppose if I'll say I want to split it into subarray which is having two elements, and then I will split into subarray which is having one element and then one element. This is also possible. Now, if I say I want to split it such that the first three element will be in one subarray and the last element will be in another subarray, this is also possible. Now, if I say I will split it into subarray such that the first element will be in the first array and the last three element will be in the second subarray, this is also possible. Now, if you say I want to split your array such that the first element will be in the first array, second element will be in the second subarray, third element will be in the third subarray, and fourth will be in the fourth subarray. So here you are basically splitting your nums into four subarray, and which is also possible, right? So here you only have to um, split the array into as many subarray as you want, and you can start your subarray from anywhere and end your subarray from any point. Like suppose if I'm starting my subarray from here, I can end it anywhere I want, and from the next element I can start my another subarray, right? So there are no restrictions on that. Now the only restriction is this: if you are having a particular subarray, then you will be starting with the positive sign, and you will keep on flipping the sign of your element in the subarray, right? Like suppose if this is my subarray, right? I have made a subarray of three element and another subarray of one, right? So let's talk about this subarray first of all. So in this subarray we have three elements, right? So the sign of the very first element will remain similar, sign of the second element will be flipped, and sign of third element will be similar. If you had four elements, then the fourth element will be flipped, right? So here one will remain one. As there is minus 2 in as a second element, then I will have to flip it, right? Because alternatively we are flipping the sign. So minus 2 will become 2, and again when I come to 3, I don't have to flip it, so 3 will become 3, right? So in this array I will get the maximum sum as 6, right? And in as the last array which we are having here, which have only one element, so we need not to flip the sign, because alternatively we are flipping and we are starting with not flipping, right? As here you can see, the first element will be as the same sign as in the original array, right? So initially we will be starting with not flipping, and then we will alternatively keep on flipping the sign, right? So what is our main concern? Basically, we have to choose a subarray such that we are able to flip the sign of the negative element, right? This is only we will be focusing on, because definitely if my elements are positive, then I don't want to flip it, right? Because adding the positive in my sum will always give me more, right? So um basically you can divide array into any number of subarray you want, and you can start your subarray from any point and you can end your subarray at any point, and then from the next point you can start your next subarray, right? So mm, like instead of actually dividing your array into subarray, what we can do is we can use dp here, right? Because Suppose in DP generally we go with two or three cases, like if you want to take, if you want to do this, if you want to do that, right? So here basically we will have two choices when you are at a particular index. So let me just start solving and then I will tell you along the way. So let us suppose this is my array, and let's say the size of my given array be n. So here I have assigned the size of the array as n. Now I will be having a function for my memoization, right? So this is the function which will be returning the maximum possible sum after splitting my array into subarrays, right? So it will take an index, it will take the sign, the current sign which we are having for element, like if the sign is positive, you will not flip element. If the sign is like, if the sign is 1, then you will not flip a particular element, and if your sign is 0, then this is the element which you have to flip, right? So alternatively we will keep on changing the sign in a particular subarray, right? And when we will be starting a new subarray, we will keep our sign as 1, right? Because the first element is always positive in the new subarray. Or you can say there's no flip in the first element of any new fresh subarray, right? So initially we will keep our sign as 1 because we don't want to flip, and then we will keep on changing our sign alternatively because for the next element we have to flip, right? So we are taking sign as argument and we are taking the actual array, the original array which we have. Now, if your current index is equal to n, then basically you have reached the end of the array and you don't have to divide your array any further into subarrays. So you will simply return 0 here. Now, let's focus here. Now, if you are at a particular index, right? So now here you will have two options. The option number one will be you will continue or you will just keep this element in the current subarray, or second option will be you will start a new subarray, right? Like suppose I have a subarray. I'm starting with the one, I have taken one. Now once I reach two, I can have two options. If I want to include my two in the current subarray, like I will be having one or two in the same subarray, or I will start a new subarray with the first element being two, right? So these two options I will have, and I have to go with both the option, and I have to find which option is giving me the maximum sum, right? Because overall we want to maximize our cost, so we will go with each case and we will see which is giving me the maximum. I will return it, right? So the first case will be, now focus on one thing also. Now suppose if you are at a particular element, right? Or basically if let me just see, if your sign is 1, it means you don't have to flip it, right? So yeah, like suppose if you are at a particular element of an array and this particular element is positive, right? So what you can do, you simply don't want to flip, right? So I will be in fact just consider both the cases simply, right? So here you will be having two cases: include element in current summary, right? So here you don't have to do anything, you just have to look at the sign, and whatever the sign you are getting, you will just add your element accordingly in your answer. So just let me make an answer. So this is going to be my answer, and currently it is 0. Now here my answer will be, suppose if I am including a current element in the current subarray, so simply I will just multiply that particular element with the sign which I have, if sign is negative, sorry. So so I have to multiply my element with -1 if my sign is 0, and I have to multiply it 1 if my sign is 1, right? So if sign sorry if sign is equal to 1, then I have to multiply it 1, otherwise I have to multiply it -1, right? So this will be my array. So I'm adding the current element in my current sovereign, then I will move to the next index of the sovereign. Here I will flip my sign, because if you are moving to the next element, then definitely alternatively you have to change the sign. So if you are taking here positive, then the next element of the subarray will be negative. And if you are taking here negative, then the next element will definitely be positive, right? Or you can say element will be flipped according to the sign. Now, if I am not going to include my element in the current subarray, then definitely I will make a new fresh subarray, right? So my answer will be like maximum of answer. And sorry, just let me here take it. So let us say this is a not include case. So I'm taking is at not. Now I will simply take my array, whatever the sign I have, because the first element of the new subarray will not be flipped, right? So here I'm taking one. Now I will move to the next index. Now I'm sure that the if I am not flipping this particular element or the first element of my new subarray, then definitely I'm going to flip the next element, right? So here I will be passing 0 as the sign of my subarray, because my sign will change accordingly alternatively, right? So I will be returning maximum of answer and whatever I am getting by not considering my current element in current array, right? So here I will be returning 0, initially sign will be 1, and this is my array. So let's try to run the recursion if it is working or not, and then we will be applying DP, right? So my recursion is working fine. Now let's apply DP. So this is going to be my DP vector, right? Where I will be storing the index. So this is the DP. And here I will be storing the index number and the sign which we have. So maximum we can have two signs, right? Either 1 or 0. So this will be 2 and minus 1, right? So this is my DP. Let me pass it also. Oh, it should be long instead. Because the definitely the maximum total cost is going to be beyond the size of the integer. That's why we are taking here long. So let me just pass it here, and let's take it by reference because we are going to make change in our DP, and let's pass it here also. Right now, if you already having your DPS filled at a particular index and at a particular sign, like if your DP is not having -1 at that place, then you will simply return whatever you have currently in your DP. So this is something you are returning, and if you don't have, you will simply go with the flow and store the result in your DP, right? So this is something which you have done here. Now let's try to run it again. Okay, so it's working well. Let me just submit it. Yeah guys, so it's working. So basically this was the entire solution and the approach. Now before going further, let me just summarize what I have done. So simply we were given an array and we have to split our given array into subarrays such that whatever the cost we are getting should be the maximum, right? Now while splitting the subarray and while taking the cost, we had to make sure that if we have some subarray, then in a particular subarray the sign of the alternative element will be flipped and not flipped accordingly, and starting with the first element not flipped, right? So as I have considered the DP, so in DP you will be having two options. If you want to include a particular element at an index I in your current subarray which you are going with right now, or you can just stop this subarray or just start a new fresh subarray, right, where you will be having your first element as the not flipped sign, right? So here we have considered both the cases, right? Because we are not only concerned about actually splitting my array into subarrays, right? Because this is not at all possible. It will be giving you TLU or something, right? So the main concern was like what will it be the sign of my current element. So if the current sign which we are passing here is negative and your element is positive, right? So definitely you will try to make this element positive only, right? And so instead of including your element in the current subarray, you will definitely try to make a new subarray, no? because sign is negative and your element is positive. So once you will just include this element in your current summary, then your cost will decrease overall, right? So in this case we will be starting new summary, and if you have a negative element and your sign is also negative, then definitely you will try to include that particular element in your current summary for sure. Because if you have a negative element, then definitely you will try to make it positive if possible, right? Because this will overall increase your cost or the total cost of which you are getting finally. So in this way we are just checking which case is giving me the maximum answer. So I'm trying just two possible cases. I will try both of them and I'll see which is giving me the maximum answer, and once I got the maximum answer, I'll simply return. So these were the two cases which you had to follow here, which you had to focus here. So yeah, this was the entire code. I will be sharing you this code in the description box. So please check it out also. I hope you understand the solution. And if you have not, you can ask in comment box. For sure, I'll resolve it out, right? So thank you so much for watching. Have a good day.